principle of flotation. Now we have read that when a body is immersed in a liquid, you have two forces acting on the body. When a body, say you have a liquid, you have a liquid, and in the liquid you immerse a body. In the liquid you immerse a body. Now when you immerse a body in a liquid, you have two forces acting on the body. One is the weight, another is the upthrust. At the center of gravity, you have the weight acting, and at the center of buoyancy, what is the center of buoyancy? It is the center of gravity of this displaced liquid. When the body was not here, here there was liquid. The center of gravity of this displaced liquid is center of buoyancy, and at that point you have the upthrust acting. What was upthrust? Upthrust was volume of the immersed part of the body into density of the liquid into G. Let me take this as small v. Small v is that volume which is immersed in the liquid. This part is small v. And what is the weight of the body? Weight of the body is m into g. If the total volume is v, mass is volume of the body into density of the body into g. So when a body is immersed in a liquid, we have two forces acting. One is the weight acting at the center of gravity. Another is the upthrust acting at the center of buoyancy. Now we might have three cases. When a body is immersed, we might have three cases. When a body is immersed in a liquid, three things might happen. When a body is immersed in a liquid, you might observe three things. One, you might see that you might observe three things. when a body is immersed in a liquid, you might observe three things. Say this is the liquid. When the body is immersed in this liquid, three things might happen. One, the body may sink. Two, the body may float on the surface. Three, the body might float with a part outside water, outside the liquid. There might be these three cases. One, the body may sink. Two, the body may float on the surface. Three, the body may float with a part outside the surface. Now, what are the three cases? What are the special three cases? In this case, the center of buoyancy and the center of gravity will be at the same position. This is the weight, this is the upthrust. Here, number one, weight of the body is greater than upthrust, therefore the body sinks. Number two, you can say the average density of the body, we have a density of the body, is greater than density of the liquid. And number three, center of buoyancy and the center of gravity, they coincide. Here the body sinks. Now case 2. Case 2 again, you have the center of gravity and the center of buoyancy at the same position. But here the body floats. This is the weight of the body. So for this case, what can we write? Number one, for this case we can write weight of the body is equal to upthrust. U is upthrust. Number two, we can write average density of the body. Density average of the body, the average density of the body is equal to the density of the liquid. And point number three, we can write B and G. Here also they coincide. Now the third case. Here this is the weight, upthrust. Here the center of buoyancy lies below the center of gravity. The center of buoyancy lies below the center of gravity. So point number one we can write. In this case, initially the upthrust becomes greater than weight. Initially, upthrust becomes greater than weight. So the body rises up, and finally what happens? Finally, weight becomes equal to upthrust, because now a smaller volume is underwater. So this volume will be involved in the upthrust. Upthrust is a volume of the body immersed. Here the full body is immersed. So when you calculate upthrust, here it will be V rho G. Here also the full body is immersed. So it will be V rho G. But here the small volume is immersed. This is small v. So upthrust will be small v rho G. Upthrust, you have to take the immersed part of the body. Number 2, here average density of the body is less than the density of the liquid. The body has a density less, so it rises up. And number 3, center of buoyancy is below center of gravity. Now these two cases fall under flotation. These two cases fall under flotation. Now what is the principle of flotation? What is the principle of flotation? According to the principle of flotation, the weight of the full floating body, the weight of the full body, the weight of a floating body is equal to the weight of the liquid displaced by its submerged part. Now what is this telling us? Say we have a body See, this is a body whose full volume is V. Total volume of the body is V. Density of the body say we write it as density of the solid. So let me write it at rho S. Since the body is a solid, now it is immersed in a liquid, and say it floats with a part of it outside. It floats in a liquid with a part of it outside. Now, what is the volume of the body inside the liquid? This part of the volume is inside the liquid. This is inside the liquid. Let this volume be small v. Let this volume be small v, which is inside the liquid. That volume is small v. Let the density of the liquid be represented by rho L. Now, according to the principle of flotation, the weight of the floating body is equal to, what is the weight of the floating body? According to the principle of flotation, weight of the floating body is equal to weight of the liquid displaced by the submerged part. What is the weight of the full body? It is volume of the body is V into density of the solid into G. Remember, volume into density is mass. Mass into G is weight. That is equal to weight of the liquid displaced. How much liquid has been displaced? The small v liquid has been displaced. Small v into density of the liquid into G. Now this G cancels. So what can I write for the law of flotation? Small v by capital V is density of solid by density of liquid. What is small v? Small v is the volume which is underwater, under the liquid. Capital V is the total volume. Rho S is the density of the solid. Rho L is the density of the liquid. So this is the formula which you will be needing to do sums for the law of flotation. Small v is a part which is immersed. Capital V is the total volume. Rho S is the density of the solid. Rho L is the density of the liquid. So remember this formula. Small v by capital V is density of solid by density of liquid. Now let us take some sums on this formula. See, you are given a sum. A rubber ball floats on water with 1/3 of its volume outside water. Find the density of rubber. Now, what is the question? The question tells us that you have a rubber ball, and this rubber ball is floating with 1/3 of its volume outside water. The part which is outside water is 1/3 of the total volume. So what is the part which is inside water? It is 2/3 of the total volume. So when you have a rubber ball with 1/3 outside water. How much is inside water? 2/3. Now this is according to the formula small v. Total volume is V. Total volume is V. And volume under water, volume inside water is 2/3 of the total volume. Now if you solve the sum, you write it in this way: according to the law of flotation, according to the law of flotation, what we have here, small v by capital V is density of solid by density of liquid. Small v is the volume inside, capital V is the total volume, rho s is the density of solid, rho L is the density of liquid. So we apply this formula over here. Small v by capital V is density of solid by density of liquid. Now I have to find the density of rubber. That is, I have to find the density of the solid. Now what is the density of the liquid? It is water. It is 1 gram per cc. 1/3 of its volume is outside. So 2/3 is inside. This V is inside. This V is what volume is inside. You have to take the V inside. So 2/3 of capital V by V is density of solid by density of liquid, which is density of solid by 1. Now this V cancels. So what we have from here, 2 by 3 is density of solid by density of water is 1 gram per centimeter cube, or you can write it as 1000 kg per meter cube. Remember, density of water is 1 gram per centimeter cube, or in MKS unit it is 1000. So 2 by 3 is density of solid by 1000 kg per meter cube. Just cross multiply. Density of solid is 2000 by 3 kg per meter cube. So my answer is 667 kg per meter cube. So my answer is 667 kg per meter cube. Now let us take another sum. Question 2. A block of wood of mass 24 kg floats on water. The volume of the wood is 0.032 meter cube. The volume, total volume of the wood, is equal to 0.032 meter cube. Find number 1, the volume of the block below the surface of water. The volume of the block below the surface of water. And number 2, the density of wood. take density of water, (1,000) kg per meter cube. Now what is the question? You have a block of wood whose mass is 24 kg. So you have a block of wood This is a block of wood. Now what is the mass for this block of wood? The mass is 24 kg. The volume of the block is 0.032 meter cube. Now we all know density of the solid is mass by volume. So mass is 24 and volume is 0.032. So this is the density of the wood. So we know the density of the solid. Now it is immersed in water and a part of it will be outside water. So what is the part inside? This part is inside. You are asked to find the volume of the block below. That means you are asked to find this volume. Let this volume be small v. Total volume V is given 0.032 and this volume is small v. Density of the liquid is 1000 kg per meter cube and density of the solid we have found out. Density of the solid we have found out. So what can we say? We can say from the law of flotation, small v by capital V is density of solid by density of liquid. Density of solid is this one. Small v we have to find out. Density of liquid is known. Capital V is known. So we have to find out small v. Here we have to find out this small v. What is this small v? Other things are known. Capital V is what? 0.032. What is the density of the solid? It is 24 by 0.032. What is the density of the liquid? It is 1000. So this 0.032 cancels from both the sides. So what do we have? Small v is 24 divided by 1000 meter cube. That is 0.024 meter cube. So the volume which is under the water, is 0.024 meter cube. This volume is 0.024 meter cube. The volume which is under this volume is this one. Now next what we have to find out? We have to find the density of wood, which we already have found out. This was part 1. Part 2 is density of wood. This you can just find out by mass by volume. Mass of the body is 24 kg. Volume of the body is 0.032. Now if you divide, it will be 7.5 into 10 to the power 2 kg per meter cube. 7.5 into 10 to the power 2 kg per meter cube. That is the density of wood. Let us take another sum. A wooden cube of side 10 centimeter has mass 700 gram. What part of it remains above water surface? While floating vertically on the water surface? Now say we have a wooden cube. We have a wooden cube of side 10 centimeter. So we have a wooden cube we have a wooden cube of side 10 centimeter. Each side is 10 centimeter. This is also 10 centimeter. This is also 10 centimeter. It's a cube. Now it is immersed in water and it floats. That means inside water, how much is it inside water? This volume is underwater. This volume is underwater. Let this volume be small v. And what is the total volume? Total volume is 10 into 10 into 10. It is a cube. Centimeter cube. And what is v? This v is 10 into 10. And let the part which is underwater be x. So small v is equal to 10 into 10 into x centimeter cube. This is 10. This is 10. This is 10. And this is x. So the volume V is length into breadth into height. Now according to the law of flotation, what can we write? According to the law of flotation, what is the formula? Small v by capital V is density of solid divided by density of liquid. Small v is a volume under water. So what is here? This is small v by capital V, which is density of solid by density of liquid. Now what is small v? Small v is the part under water. So it is 10 into x. What is capital V is the total volume. 10 into 10 into 10. I have to find the volume which is above. So let me first find out the volume which is beneath, and then we can find out the volume which is above, which is 10 minus x, because the total is 10. This is x. First let me find out x. Then I can find out the part which is above water, which will be total height is 10. Total height is 10. This is 10 centimeter. And the part which is in is x. So part which is above is 10 minus x. So this can be written as density of solid. Now how do we find the density of solid, children? Now we know density of solid is mass by volume. What is the mass? Mass is 700 gram. What is the volume? Volume is 10 into 10 into 10. So 2 zeros cancel. So density is 7 by 10 gram per centimeter cube. Because we are doing in CGS unit, this is gram and this is in centimeter. So density of solid is 7 by 10, and density of water is 1. So this 110 cancels. What we have, x by 10 is equal to 7 by 10. So 10 cancels. So x is 7 centimeter. So the part which is underwater is 7. So what is the part which is above water? It is 10 minus x. Therefore, you are asked what part. So part which remains above the water surface. Above the water surface is equal to 10 minus 7 centimeter. It is 10 minus 7. X is 7. So it is answer is 3 centimeter. So 3 centimeter remains above. If 7 centimeter is beneath, if this is 7, total is 10, then the part which is above is 3 centimeter. 3 centimeter remains above the water. Let us take another sum. A piece of wax floats on brine. It floats on brine solution. What fraction of its volume is immersed? What fraction of its volume is immersed? You are given density of the solid, that is density of wax, which is the density of solid, is given as 0.95 gram per centimeter cube, and density of brine, which is my density of the liquid, it is 1.1 gram per centimeter cube. Now what is the question? Question is, you have a piece of wax which floats in brine. This is wax, and this wax floats in brine solution. It floats in brine solution. This is brine. Density of the liquid is given as 1.1 gram per centimeter cube. Density of solid is given as 0.95 gram per centimeter cube. The part which is under brine is small v, and the total volume is capital V. This is my total volume, and this is my volume under brine. Now you have to find out what fraction of its volume is immersed. That means you have to find out small v by capital V. What is the fraction? Here you have to find the fraction of the wax which is under the brine solution. Now according to the law of flotation, what do we have? Small v by capital V is density of solid by density of liquid. You have to find out this fraction. That means this is equal to density of solid is 0.95. What is density of liquid? It is 1.1. It is 0.95 by 1.1. So this is 95 by 110. So if you calculate, this will come out to be 0.86. You are asked what fraction will be immersed. That means you are asked small v by capital V. What fraction, ratio? So the answer is 0.86. This fraction of wax will be immersed in brine solution.